Okay, so today we're starting to learn about complex numbers. And the main concept, which is like in the very, very foundation of the whole story of the complex numbers, is introducing of the imaginary number I, which is solution to I squared equals -1. So I equal square root of -1. The first, which is completely, we never used that before, we always said we cannot take square root of negative number. Now we will know that we can, using imaginary I, imaginary, like sort of one I. The first idea about possibility of taking roots from the negative numbers were at least known. First mentioned was by ancient Greek Heron. Remember Heron's formula for area of the triangle? The same Heron.
S minus.
Yeah, P square root of semi-perimeter times S minus A, S minus B, S minus C. The same guy was started introducing idea of thinking about taking square root of negative numbers. But then this was introduced by the Italian mathematician Girolamo Cardano in 16th century. Then another Italian mathematician, Raphael Bombelli. But the biggest development in the complex numbers belongs to Euler. You know Euler's number? And Euler developed made a big development. Also another mathematician, Gauss, who when you will be learning about the normal distribution, you will be mentioning him as well. So we have the imaginary number. First, if we know that number I, then we have I squared equals -1. What will be I cube equal?
Negative I.
We multiply -1 by I, we get negative I. Because we multiply negative result of square, we multiply by I. What will be I in the power of 4 equal? 1. Because negative I times negative I times I will be negative I squared equal -1. So you get I. Then it will be repeating. I in the power of 5 will be equal I in the power of 6 will be -1, I in the power of 7 equals I in the power of 8 will be equal 1. So what will be, for example, I in the power of 15? What will be I in the power of 15? Negative I, yes, because we get I in the power of 16. Every 4 times it repeats. Every 4 times it repeats. So that is powers of I. Now, complex number effectively is a 2-dimensional number. This is just imaginary I, but if we write a complex number, we will use letter Z for complex numbers, and Z equals A plus BI, where A and B both are real numbers. Okay, so for example, Z equals 3 plus 2I, or Z 2 equals -2 minus I. That's all complex numbers. Effectively, it's a two-dimensional numbers. Because if you look on the Cartesian plane, and we have this part will be imaginary part Z, this is a real Z. So how we represent number 3 plus 2i here? 3, 2, and that point will be 3 plus 2i. Minus 2 minus i, minus 2, minus 1, this will be minus 2 minus i.
Is that only two-dimensional?
Yeah, they're two-dimensional.
Like I is always the y-axis.
Yes. This is imaginary part. This is imaginary part. This is the real part. So how we add and subtract complex numbers? Very simple. If we add, for example, Z1 plus Z2, we add their real parts.
1.
3 plus negative 2, 1, 2i plus negative I, 1 plus I. What will be Z1 minus Z2?
5 plus 3i.
Will be 5 plus 3i. Make sense? Very simple. Now, if you multiply complex number by the scalar, by the real number. For example, if you multiply 5 times 2i minus, 5 times 2 minus 5i. What that will be equal, we just expand brackets as usual. We get 10 minus 25. Make sense?
Got you.
So, quite straightforward. Another example. Another example is...
Wait, why?
Hmm?
Why?
What do you mean by?
Why does it work this way? Why does subtraction and addition work this way? Why do you do this with the I? I don't understand. Am I-
Addition, we add the
Oh, I'm thinking
real
of course,
parts
of course. I just think that-
and we
sorry.
add imaginary parts. Now, example, if we multiply root 2i, root 2i times root 2i times I minus root 2 times I minus root 2 equal root 2i times I times I, which is negative 1. So negative root 2, we have minus 2i, minus 2i. Because root 2 times negative root 2 is negative 2. Now, another idea that we will include today is pretty much just introduction to complex numbers and modulus of the complex number.
This says
If we,
interesting vector applications. There's interesting vector applications.
yeah, a plus bi, complex number, then modulus z, modulus complex number is equal square root of a squared plus b squared. That's called modulus of the complex number. We will develop this idea and what it leads to in the following lessons. And
You seem very passionate about complex numbers.
I love complex numbers.
That's fun to say. There must be some-
I love complex numbers.
What did you say?
So
And-
that's condescending.
Yeah, that's pretty much all introduction to complex numbers. So we started slowly at the first lesson after the exams. So like, subscribe and donate to help fight terrorist countries and organizations like Russia, Iran, Hamas, etc., support Ukraine and Israel.